So for today's video, we're going to go over 6 examples of some of the basic algebra properties and concepts we talked about in last time's video. Just as a quick recap, we talked about the associative property of addition and multiplication. We talked about the commutative property of addition and multiplication. And then we also talked about the distributive property. We can go into more details on that in the previous video if you want to look back at that. But we're going to use all 3 of those properties in today's video. And so we're going to start off with our first problem, which is going to be, we'll start off kind of simple, and then we'll work our way up. So this is 3 times the group of 4 plus 7. Now, you can do this one of 2 ways. You can follow PEMDAS, which says that you would do 4 plus 7 first, you'll get 11, and then you'll multiply by 3, and you'll get 33. The other thing is you can also technically use the distributive property now that you've learned it, and I'll do that down here. We'll have 3 times 4 plus 7, I'll just rewrite it, and if I distribute the 3 across to both terms, I can then get 3 times 4 is 12, 3 times 7 is 21. Adding that together, we get 33 also. Either way works, but in this case, the answer is 33. You can either use PEMDAS, which says to do parentheses first, or you can just distribute across. In the next problem, we will need to use the distributive property. It'll be very similar. This time around, we have 12 times the group of x minus 4. In this case, we can't use PEMDAS, parentheses, brackets or braces, because we don't know what x is. X is a variable. And so we have no real understanding of what this is. It's a giant question mark for us. Okay. So all we can do in this case is use the distributive property to simplify these problems out. So 12 times x is going to be 12x. I'm going to carry the minus over. 12 times 4 now is 48. And that is the answer because I can't do anything else. All I can do is simplify. So all I have is 12x minus 48. In the next problem, we'll get a bit more advanced. Our next problem we're going to have is 3x times the group of 4 plus 7x end group minus 12 plus 3x. Let me write that x a little bit better. Kind of ran out of room. There we go. Okay. So in this case, we'll use PEMDAS to solve our problems first. We have the brackets. We have 4 plus 7x, so we will need to take care of that. I can't subtract the 12 yet. I can't add the 3x yet. So I have to first distribute this 3 across, the 3x across, I should say. So 3x times 4 is going to be 12x. 3x times 7x. 3 times 7 is going to be 21. And then x times x gets us x squared. We have 2 x's. Or technically we don't have 2 x's, we just get x squared. And then I'm going to bring down the other 2 terms. We're going to have minus 12 and plus 3x. Okay. Now in this case, I forgot my addition sign. In this case now we need to simplify. And so we're going to combine like terms. I see 2 like terms that I can work with. One is this 12x, the other one is the 3x. And so 12x, which is positive, plus 3x will get me 15x. I'm just going to write it here in the front for now, and then we'll rearrange afterwards. And I'm just going to carry down the 21x squared and then the minus 12. Some of you may already be thinking ahead, and you'll know that when we have problems, such as this one, we rearrange by the ascending power. So in other words, 21x squared will move to the very front of the problem because it has the highest amount of exponents in this case. And so then we'll rearrange this to where it's now 21x squared. 15x is positive, so we'll just say plus 15x, and then we'll subtract the 12, and that is our answer. Okay, we'll move on to our next problem. Let me go down to a new page for this. This next problem will be a bit more challenging than the previous one. We have free z, so that is a z, which is another variable. And then we're going to have parentheses again, negative 4y plus 12 plus 12zy. So this last term has both z and y in it. Okay? So that's a little bit more unique than what we've seen before. Also, we're starting with a negative 4, and we have two different variables. We have z and y that we're going to have to multiply across with. So we'll use the distributive property first. We'll distribute free z to both terms. Here, in our first term, free times negative 4 is negative 12. And then z and y we can't combine, they just go along, and so we have zy. And then in our next term, free times 12 is 36, and then we carry the z. So we get 36z. And then I'm just going to plus 12zy. Almost ran out right there. Okay. Now the only thing left to do is combine like terms. And so in this case, I have two like terms. I'll use red for this. I have the negative 12zy, and then I have the positive 12zy. The other term I have is the 36z. It only has one z. It doesn't have a y, so I can't combine it with anything else. So it's just going to remain separate. And so when we combine these, negative 12 and positive 12 make 0. So in essence, I have 0zy plus 36z. Now, when we say we have 0zy, that means we have no zy terms. And since we have no zy terms, we can simply just remove it entirely. And so our answer is 36z. Okay. Next problem. We'll have two more problems. They're going to get increasingly harder. So these last two are more challenging. We'll start off with free x squared combined with 2x plus 7 in parentheses minus 2x plus 5. Okay. Okay. So in this case, we now have two terms that we need to distribute across. We need to work that out first. So in our first term, we're going to distribute the free x squared across. In our next term, we're going to distribute the negative 2 across. And keep in mind that we're going to distribute the subtraction sign also here. Whenever you are distributing with either a subtraction sign or a negative sign, you need to distribute it across to all terms. Otherwise, your answer is not going to come out right. Okay. If you want to know why, the reason for that is subtraction, and this is just shorthand. I'm going to do this in orange. subtraction, and that's like in air quotes, is technically adding a negative number. So when we say like subtracting 2, that's really adding negative 2. And so that's the way you can think about it, is this is really just negative 2 being distributed to the 2x and the 5. All right, enough of a side tangent. Let's go ahead and distribute across. 3x squared times 2x. 3 times 2 is going to be 6. I'm going to bring it down just a bit. It's going to be 6. X squared times x is going to get me x cubed. 3x squared times 7 is going to get me plus 21x squared. Okay, that's my first term. My next term is negative 2 times 2x. That gets me minus 4x. And then negative 2 times 5 gets me minus 10. All right. In this scenario, we need to see, okay, is there any like terms or any simplifying we can do? And in this case, there's nothing we can simplify. 6x cubed stands alone. 21x squared has no common terms because it's x squared. We don't have any other x squared terms. 4x, same idea, has no 4x terms. And 10 is just 10. It can't combine with any of the x's because it doesn't have a variable. So in this case, I'm just going to rewrite what we already wrote. Our answer is 6x cubed plus 21x squared minus 4x minus 10. That's our answer. Okay. Last term. Okay. Last problem. This is going to take some space, so I'm going to have to write kind of tiny here. All right, to start off, we're going to have 6xy, and then we're going to have parentheses 15x plus 4, end parentheses, minus 3z, starting a new set of parentheses, we're going to have 2x plus 5y, end parentheses, and then we're going to subtract 13xy. I almost ran out of room there. That is 13xy there. Okay. Okay. Ooh. A lot of distribution to do here. So let's go ahead and distribute across. We have 6xy that we will be distributing, and we also have a negative 3z we will be distributing. In our first term, we have 6xy times 15x. So 6 times 15 is 90. And then xy times x gets me x squared y. Okay, I have one x term in both of these, so when I multiply them together, I get x squared. Now for the other term, 6xy times 4 gets me 24xy. Okay. In my next term, I have negative 3z times 2x, so that's going to get me minus 6zx, or you can say xz. Technically, either one works. In the next term, you're going to have negative 3z times 5y, so that'll get me minus 15zy. And then at the very end, we also have the minus 13xy. Okay. So now we need to see, is there any terms we can combine? Let's see. What I like to do in this case, if you ever run into this problem, is I like to draw little lines underneath each of my like terms. So here I'm going to draw one line, and I have x squared y. Do I see any other x squared y terms here? No. So then I'm going to go to 24xy. I'm going to draw two lines. And I say, do I see any xy terms here? I do, I have the minus 13xy. Okay. Then 6zx, I don't have any other like terms, and the 15 stands alone. That would get 4 terms, or 4 lines, just for consistency. So in this case, the only ones that I can combine are these two. Okay, let's go ahead and do that. So I'm going to have 90x squared y still around. So that's 90x squared y. I'm now going to combine my xy terms. 24xy minus 13xy, that'll give me plus 11xy. I'm going to carry down the 6zx, and then I'm going to carry down the 15zy. Okay. In this problem here, all of my terms, I have one squared term, which is the x squared and 90x squared y. That's my highest power term, so I'll leave that at the front. All of my other terms in this problem all have single powers, so I don't need to rearrange them at all. I don't have like an x cubed term that would need to go to the front, or a z to the 4th term that would need to go to the front. So in this case, my answer is simplified. And that's my answer. And that will do it for this video.